Okay, so we recall what we have discussed in the last class. Previously, we have discussed the idea of Taylor's theorem and then Taylor series, Maclaurin's theorem, Maclaurin series. But in the last class, I have followed this equation. Okay. That is okay. This expression is also okay. This expression is also okay, but remember, it is saying that remainder after n terms. So that is why we are taking h to the power n by n factorial. But I have seen some other textbook which are actually following different notation. So their notation is also correct, and in fact, the other notation is more popular. So this notation you can find in US Growal. Okay. But I would recommend not to follow this notation. I'm not telling this is wrong. This is also correct. But you have to mention that this is a remainder after n terms. The difference, the confusion may arise when people will like the other authors, other textbook will write Rn equals to Rnx equals to h to the power n plus 1 by n plus 1 factorial. And then in n plus 1 a plus theta h. So there will be the confusion. So from now onwards, I recommend not to follow this notation. Try to follow this one. So that is why I am going to recall all the notations that we have discussed in the last class, and we redefine. Try to avoid these notations to not to make any confusion about this. So this notations is actually taken from
Sir,
textbook. Yes, tell me.
sir, they have mentioned after 3 times, after n times, that one is the remainder, sir. So it
Yes,
will
yes,
be
the
right.
after enter. Yeah, tell me.
Then it will be correct, na, sir. After n
Yeah,
times
yeah,
means
yeah. Yes,
h4
that
n
is
by n.
correct. I'm telling again, I'm telling it is correct also. I'm not telling it is wrong. But there are several, uh, normally in other textbook, they just write this remainder term as this one. Okay. But here, you have to mention every time that this Rn means this one. Okay. But most popular notation is this one.
Okay, sir.
So both are correct. Okay. But if you want to mention, if you are using this notation, then you have to mention this one every time. This is after n terms. So this is correct also. I'm not telling anything wrong. Both are correct. I'm telling the most popular approach.
Okay, sir.
Okay. Also, this calculus book is a very good book. I have included in the book folder. You can access it also. So there, from there, I have taken this definition again. So when we say about the theorem, okay, then it will have some hypothesis, and based on that hypothesis, we will have some conclusion. So what are those hypotheses? Okay, whenever theorem, mathematicians actually they make fun of theories, because if you are a mathematician, then I believe there is a saying that people make fun of it. I believe in theorems. But not in theories. Theory can be wrong, because this can be conspiracy theory, there can be some. Okay, so theorems are always correct. Theories can be wrong. So theorem means it will have some hypothesis. It will have some hypothesis. And based on this hypothesis, there will be one conclusion. For example, here the hypothesis are f is a n times n plus 1 times derivable function. Okay, these are hypotheses. These are on the closed interval AB. And nth derivative is differentiable on the open interval AB. Then the conclusion is that if these properties, these conditions are satisfied, okay, these two conditions, then there exists a C point in between A and B, then this will satisfy. Now, when we call it a formula, instead of theorem, we call it a formula.
Sir, there should be f n plus 1, right, sir, from open interval A to B, differentiable. The second statement.
Yeah, that is okay. Yeah, there is the confusion. In fact, I have taken the snapshot. Okay, so there you are taking open interval differentiable. It is telling about continuity. Okay, when we talk about continuity, we will tell about the open intervals. It is not n plus 1. It is n actually. Continuity will be defined on the closed interval. All the derivatives are continuity. N order derivatives are actually continuous. And then Fn is actually differentiable on the open interval. Because differentiability is more strong criteria. Differentiability will imply continuity. But continuity does not imply differentiability. There are some continuous function, for example, mod x. It is a continuous function, but it is not differentiable at the point x equals to 0. It is a continuous function, but it is not differentiable. So that is why it is correct. And the theorem says it will have this expression. Okay. Now, when we talk about the remainder form, then this theorem will be converted into Taylor formula. So we'll call this one as Taylor formula. And the remainder, of course, this is Lagrange's form of remainder.
Sir, can you please show the previous slide for 1 minute?
Yes. Just
Done, sir. Thank you.
okay. So Taylor formula will be when we call that Rn, because I have said that we use Taylor's theorem for approximation of a function, and we have seen how we can actually approximate for e power x. This can be approximated by a polynomial Pn x after some Pnx, for example, 1 plus x square by 2 plus x cube by 6, 1 plus x, okay, all this Pnx. Because after some time, after some terms, e power x, whatever you put, for example, 2 point e equals to whatever the value you get for particular x, if you fix x, then the value is also going to approach to the point. That means the remainder term. So this is known as formula when we use the concept of remainder. Now, as you know that the function, given function, so this remainder form Rnx, what would be the error? If x minus this is Plx. So that is the error term. In fact, because one of the variable, either x or c, is unknown to us, so that is why we don't know. It is just telling that c is in between the interval a to x. So unless you know the value of c, you cannot calculate the exact error. What could be the exact error? But there is a theorem which called error estimation theorem, that how much error can be there for that particular case. So that we can calculate. I mean, if we do not study the error calculation, then there is no point of starting this Taylor's theorem. So this is a bonus topic. In fact, you don't know the converges. Have you studied the concept of converges? Series convergent, sequence convergent? I think you have not studied, but yeah.
No, sir.
No, sir.
Okay, so you leave it this topic. It is not part of our syllabus. Maybe you will learn in the second semester what is the meaning of convergence. So it is not actually. In fact, in geometrical sense, I can just give you the convergence meaning. When, for example, f of xn, let us consider 1 by n. Okay. This converges, the limit is actually going to 0, right? 1 by n for n equals to 1, 2, 3, and so on. So convergence meaning after some term, that means this will series, if you take this Sn equals to k equals to 1 to n, and this is defined by 1 by k. Okay. Or yeah, so any term you can write. Then
Sir,
Sn.
sir, are you
And
telling
then-
about limits for convergence?
No, the limit of a series actually.
Yeah,
This is a
we have
series, right?
studied limits. Limits we have studied.
Limit of a function. Limit of series you have not studied. You have studied limits of a function. Okay,
Yes.
anyway, you forget about it. Okay, this is not part of our syllabus. In fact, the syllabus has been mentioned that Taylor's formula, Taylor series. Without discussing power series, we cannot go to the Taylor series or Taylor's theorem. Anyway, since the senior professors have designed this syllabus, so we have to follow their instructions. So anyway, in fact, we have the liberty to go and discuss the power series and convergence also. But anyway, we should not focus on other thing. Geometrically, convergence meaning, I think you have studied the convergent rate in physics, right?
No, sir.
Convergent rays you have not studied?
Oh, convergent ratio. Yes, sir. Yes, sir.
Yeah, rays you have studied. That means
Oh, yes, sir. we
all the rays are actually converging to one point, are meeting at one point. How about divergent? From one point, they will disperse. They will go away from each other, and here it will converge to one point. From one point, they are diverging to one. So this is called divergent. Divergent, and this is called convergent. Briefly, roughly speaking, this is convergent and this is divergent. For example, if you take Sn equals to 1, k equals to 1 to 1 by k. For example, is 100. That means you will take 100 to the, maybe you can take it not 100, 1 lakh. Okay. Which means you will take the sum of first 1 lakh numbers. K equals to 1 to 1 lakh. Okay, and then 1 by k. Then the number will be very much 0, 0. After some time, maybe 1 plus 1 by 2 plus that 1 by 0, 0, 0. Okay. Now, if you increase the numbers, the total sum, okay, between, for example, Sn plus 1 minus Sn, okay, this is going to be actually 0, the difference. That means after some terms, okay, after some terms, all are actually within some limits. For example, if you look at the curve, the cos x, okay, we wanted to approximate the values here. The difference between the P0, for example, here, P0 x and minus cos x. Okay, you can see the difference here. They are matching only at 1 point, at x equals to 0. But if you think about the P2, that is, so it is actually matching here. This many points it is matching. You can see that all are matching, all are converging to 1 point. All are meeting at 1 point. So this is known as convergence. So anyway, this is a rough idea of convergence. Now, as you know that Taylor's formula will be used to approximate the functions. So we'll try to approximate the functions. Some of the functions we will try to approximate. And then, okay, we will also try to find out the error. How much error can be there? We do not have the method to find the exact error, but we can always find the bound of the error. That this much error, for example, error can be bounded by 0.00005 or something. That means this is the original curve, and we are trying to approximate the function. Okay. Now the difference between this, we want to make it difference between these two curves. Okay, we want to make it as 0.00 function. So maybe this is fx and this is pnx. So our aim is to, for particular x, for a given x value for x naught, the difference we want to make it f of x naught minus pn x naught should be bounded by this 0 point, the error. Let us call it epsilon. The meaning of this. Now the formula for finding the error is this one. The remainder term Rnx, which is bounded by m, is the bound for the derivative or nth order derivative is bounded by the value, that is m, we call it. For example, if your function is sin x, f of x is sin x. Whatever you take it, m plus 1 of t, This is going to be either minus 1 times either cosine of x or sine of x, depending on the n value. Now, if you take the determinant, not absolute value, not determinant, this is the absolute value, then it is going to bound by 1, because the absolute value of cosine x or sine x is bounded by 1. Okay. So this is the meaning of bound of a function. For example, okay. And this can be written as this form. So this is the error formula, finding the error. In fact, we can prove it. The proof is actually very simple. Try to verify. Verify means go through it. That as n tends to infinity, this error will go to 0. That means whenever you increase the order of the polynomial, degree of the polynomial, n tends to infinity. Okay. Then what happens? The given function fx equals to sin x. The 19 order polynomial P19 is actually matching this many values from up to here to up to here. So this many values it is matching over the P19. So for a given function, that is a sin x, we are approximating this function up to this interval, from 0 to 8, almost 8. We are getting the same value of this function. So up to this we are getting same value. After that there are some errors. It is not matching, so we are getting some error. So that error is given by after some, depending on the need, we will be defining the error. For example, error is defined as 1005. Okay. So this kind of situations we will study. Okay. And that is done by the Taylor series formula, because we have to allow n tends to infinity. So that is why whenever we allow n tends to infinity, the Taylor formula becomes Taylor series. Okay. So Taylor series generated by f at the point around the point x equals to a is denoted by and defined by this one. Okay. So all these values are will be expressions are same. Here we will put just 3 dots, dot, dot, dot. That means it goes to infinity. In fact, you have studied what is the meaning of series. Okay. Now, when we have finite numbers, okay, then we'll call it a, if these are not there, then we call it a Taylor's theorem. Okay. Once we allow n tends to infinity, we call it a Taylor series. Now, if we put a equals to x equals to 0, that means the Taylor series evaluated around the point x equals to 0. So that is known as Macron series. This is due to the mathematicians, they have proposed this series. So this is the Maclaurin series, f of 0, x into f dash of f of 0. Now, so what are the things that we need to remember? Okay, this is another definition. It's called Taylor polynomial of order n. the same topic, whenever the number of terms are actually changing, okay, the expression changes, you call it a Taylor polynomial. A polynomial will have of n degree. You cannot have a polynomial of infinite degree. A polynomial will have a finite degree. Normally, polynomial will have this expression. So this polynomial will be called Taylor's polynomial. These concepts are from this book. Now, the applications of Taylor's theorem, or whatever you call it, Taylor's theorem or Taylor's polynomial. So that can be seen here. For example, 1, the function fx equals to sin x approximated by the Taylor polynomial of degree 3 about the point x equals to 0. Find C such that the error satisfies this relation. Okay. And for all x in the interval 0 to c. So that means you have to, x equals to 0 is given. So f of x equals to f of 0, okay, plus x into f dash of 0 plus x square by 2 factorial into f dash of f double dash of 0 plus x cube plus by 3 factorial into f triple dash of x. Not x equals to 0 is given. Okay. And then we have to write up to 3 degree polynomial is given. So after that, what we will write? This is R3 x. If you remember the expression for this one, the remainder term is here actually now. Okay. Rn x. So R3x will be x to the power x minus a whole to the power n plus 1. So 3 plus 1, that is 4. Okay. And then 4 factorial by f power 4 of some c. So here it is. So this is the 4th order. So we are not writing about this because it is only saying up to 3 order. So this would be the acting formula, the working formula. For example, if you have second example,
Sir,
obtain-
but in example 1, the polynomial will become of fourth order, 4th degree.
no, that is why we will not take. Not 4 degree. This is 3 degree. Degree is 3. It may have 4 terms. This is first term. This is second term. This is third term. This is fourth term. But it is not 4 degree. Degree will be decided by the power of the x.
Okay, sir.
Okay, see here. Here is R3. What is Rn? Rn is x minus a whole to the power n plus 1 divided by n plus 1 factorial f of n plus 1 into c. Remember the remainder form? So that is why if you put here 3, so put here 3, so put here 3, so this becomes 4. Okay. So for second order, we'll see how to solve it. We'll solve the problem. And before that, let us understand the problems first. So whenever obtain Taylor's polynomial expression, here you have to find out Taylor polynomial. Okay. As error terms, so that the error terms goes to 0 as n tends to infinity. Hence, write the Taylor series expansion. So you need to write in terms of this form. A equals to 1 to infinity. So this is something like that. Maybe you will get A1 plus A2 plus dot dot dot. So series form. Not only that, it can also be used to find out the particular value of approximate value of cosine 31 degree up to 4 decimal places. Okay. So these 4 examples we'll try to look into it. So first, we have to remember the topics that we need to remember here is, first one is Taylor's theorem. Taylor's theorem says this one: fx can be approximated by polynomial of degree n, where n can be written as of this form. And then remainder estimation formula, we have the error. How much error can be there between the two functions? Error. Then Taylor series is this one. That means n tends to infinity. We will allow n tends to infinity. Okay. Remember, sometimes people may give many dots, dot, 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 dot. It is actually not correct. By notation, we'll have 3 dots is sufficient to indicate the infinity. 3 dot is sufficient. Okay. So Maclaurin series is this one. Whenever we say about series, so it will indicate about the n tends to infinity dots. Okay. So it is evaluated around the point 0, a equals to 0. And then Taylor polynomial is a finite number of terms will be there. So up to n, we will write Taylor polynomial, Pnx. So with this 5 information, we will try to apply these concepts. The first one is, so let us write solution. So we have fx equals to f of 0, since a equals to 0 here, given. Okay. In fact, if you write it in terms of AB, f of b type formula, f of 0 plus x into f of 0, x square by 2 factorial f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus r3x. Okay, for fx equals to sin x, but we have f of 0 equals to 0, because we need to calculate this one. So now we need to calculate this one also. So f dash of x, this is my sine, cosine. So this will imply f of, and let us not imply, because we have to substitute. So we'll write and f dash of 0 is equals to 1. F double dash of x minus sine of x, and f double dash of 0, this becomes 0. F triple dash of x becomes cosine x, and f triple dash of 0, this becomes minus 1. How about f4 of x? This is plus sine of x, and f4, let us say some c. Okay. So this becomes What is it? Sine of C. Okay, right. So this is the term that we need. So we need to calculate. So what is f? Okay, now if you try to actually look into the graph, so how do you actually indicate? So the required approximation is given by fx equals to sin x, which is approximated by f of 0 plus x into f dash of 0 plus x square by 2 factorial. So let us write it 2 only. F double dash of 0 plus x cube by 6 f triple dash of x, not x, it is 0. Okay. So let us write up to 3, because here if you write R3, then this is not going to be any more a polynomial of 3 degree. Okay, so we'll write up to, we'll actually eliminate R3 now. We'll calculate R3x separately. Our task is to find out the polynomial of degree 3. So f of 0 is 0 plus x times 1 plus x square by 2 times 0 plus x cube by 6, this is minus 1. If you go back and check the values, so f dash of 0 is 1, if the third derivative of 0, f triple dash of 0 is also minus 1. Other values are 0. Okay. So thus the polynomial becomes x cube by 6. A polynomial of degree 3. So this is our approximation, okay, approximate polynomial for the given function up to 3 degree polynomial, because you have to do it 3 degree polynomial only. Okay, and you have to evaluate about the point x equals to 0. Now find the value of C such that the error satisfies R3 x equals to this relation. That means error cannot be more than this, okay, in this interval. So let us calculate. Now if you try to look into the picture, then what happens is actually, so here, the red curve is actually sin x curve, and then the black curve is x cube by x minus x cube by 6, and the third curve, that is blue curve, that is a polynomial of degree 5 actually. Okay. This is just to show you that how much if we increase the degree of a polynomial, then it is giving us more accurate data. But if you look at the point here, yeah, here actually, so degree 3, okay. Yeah, here it is. Oh. If you look at here, the figure, so this is our sin x, and this one is our x minus x cube by 6. So you can see that there is a gap. It is not matching at the value of when x equals to 1.06, it is not matching. So up to which it can match after that we have to calculate. So after what value? And the error is, that means the difference between this curve and this curve, the length is actually, for example, this distance is bounded by 0.001. So this is the distance we have to calculate. This d we need to calculate. This R3. Okay. So the maximum error in the interval zero to c is given by, what is the formula? This is R3. The absolute value of this R3 x is bounded by, so R3x, let us write, we have already calculated. Here it is. X minus 0 whole to the power 4 by n. N is R3. So that is 3 plus 1 factorial times F4 of C. Okay. And this is bounded by maximum of here x to the power 4 by 4 factorial is 24 into maximum of the value sine C, or you can write sine C, and the value of x, if you write here AC, then you can write x also in terms of, because we need to satisfy this relation. Okay, this particular C, we need to find the range of C, that is what is the maximum value of C, so that this relation holds. So 0 less than x less than C. Okay, so what happens here, we can write here now maximum of this, so maximum will be at here, so C to the power 4 by 24, and maximum of this value, what is it? Whatever may be the value of C, it is 1. Maximum value of sine is 1, sine x is 1. And this relation is given less than equals to 0.001. It is given. So that means we will satisfy this is 0.001. Now from here we can find out the value of C. Thus we have C to the power 4, 24 less equals to 0.001. So from here you will find out C equals to C to the power 4 equals to less than equals to, so 0.024. From here you get C equals to 0.3936. Okay. Hence, for all x belonging to the range 0 to C, so in place of C we can write 0.3936. The error criteria is satisfied. Now the meaning is to take here. Okay. So sine curve, it is going starting from 0 to it will go up. Okay, and then what you are having? You are having an polynomial which is matching up to here. Okay, after this is going. So maybe this is 0 to C. So this is okay, not that much from here, 0.3936 up to this point. The difference between the sine curve and the polynomial is actually less than this one. This will satisfy. That means this many points, it is actually matching with the given curve. So that is the actual meaning of error. If you go back and check the second problem, so the second problem was okay. So this is your task to find out the error. I have included the error term, so try to find out. So this is 2. Okay. Now what you have to do is you need to find out the obtain a Taylor polynomial expansion for the function f(x) equals to sin x about x equals to pi by 4. Okay. So for let us write down for f(x) equals to sin x, what we get? F dash of x is cosine x, f double dash of x, we get minus sin x. F triple dash of x, what we get? Minus cosine x. F4 dash x, what we get? Plus sin x. Then if you do for odd number, what you will get? You will get only cosine x, and then if you do again sixth, you will get here minus sin x. So you can write here generalized form, that is f of 2n plus 1 odd number fx greater equals to minus 1 to the power n and then cosine x. So from here you can write f2n of x equals to minus 1 to the power n. Okay. Sin x for all n greater equals to 0. Because if you substitute n equals to 0, then so this is becoming 1. So n to the minus 1 to the power 0 is 1. Cosine of x, it is getting cosine. If you put equals to 0, then everything becomes 0. If you put 1, then 2. So from 2 you get n equals to 1. Then you get this relation. Okay. So this is our generalized form. We have found it. Okay. Now, because we have to find out it as in terms of pi by 4. Okay. So f of 2n plus 1 of pi by 4. This becomes minus 1 to the power n cosine pi by 4, which is nothing but 1 by root 2. Similarly, for here also we will get x minus 1 whole to the power n 1 by root 2. Okay. Hence, the Taylor series expansion is of fx is given by fx equals to sin x is given by okay about x equals to pi by 4. F of x equals to f of pi by 4 plus x minus pi by 4 times f dash of pi by 4 plus x minus pi by 4 whole square into f double dash by 2 factorial of pi by 4. Okay. Then after that 1 by n factorial. Let us not write 1 by x minus pi by 4 to the power n by n factorial. Okay, pi by 4 plus we can write dot 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 because we are writing series. We can, if you write formula, Taylor's formula, okay, then we can write here Rn x. Okay. So for Rn x equals to x to the power x minus pi by 4 whole to the power n plus 1 divided by n plus 1 factorial. Then f of n plus 1 of c, where c belongs to between the interval x to pi by 4. Okay. So for n equals to 2n, what you will get? R to n x. X minus pi by 4 by 2n plus 1 divided by 2n plus 1 factorial f of 2n plus 1 by c. Okay, now this is, if you take the absolute value, this would be bounded by this is x minus pi by 4 2n plus 1 divided by 2n plus 1 factorial times 1. Okay, because this is either sin x or cosine x. So this absolute value will be bounded by 1. Okay. Now if you allow n tends to infinity, what will happen? This term will go to 0, right? Because for particular x, for a fixed x is fixed, pi by 4 is fixed, this term is fixed, and then if you allow n tends to infinity, the denominator will increase and the whole term, the fraction will become 0. So that is why R2n x goes to 0 as n tends to infinity. Similarly, R2n plus 1 x also goes to 0 as n tends to infinity. So fx equals to sin x. So fx equals to sin x we have seen, we have assumed, and this expression was equal to f of pi by 4 plus x minus pi by 4 times f dash of pi by 4 plus x minus pi by 4 2 factorial by f double dash pi by 4 plus then x minus pi by 4 whole cube by 3 factorial f double triple dash by pi by 4 plus we can write dot dot dot, because we have seen that Rn whatever, maybe it is 2 plus 2n or 2 plus, it is going to 0 as n tends to infinity. Okay, so that is why we can call it now a series. So Taylor series is given by, what is it, sin x equals to f of pi by 4, that is 1 by root 2 plus x minus pi by 4. Okay, let us write x minus pi by 4 times f dash of pi by 4. So since this was, so this one was, so minus 1 times pi by 4, n equals to 1. So minus pi by minus 1 root. So here we can write 1 by root 2 plus 1 by 2, 2 factorial is 2. So this is 1 by x minus pi by 4 whole square. For this one we have minus 1 by root 2. Similarly, for this one, 1 by 6, 3 factorial. So this would become x minus pi by 4 whole cube. Then, okay, multiply. What is multiply? This multiplication was minus 1 by root 2 and plus dot dot dot. That is sin x, the Taylor series expansion will be 1 by root 2. Take this outside. So this will be 1 plus x minus pi by 4 plus, not plus, now it can be minus. So this here it is negative is there. So x minus pi by 4 whole square. Also negative 1 by 6 x minus pi by 4 whole cube plus dot dot dot. So that would be our final answer. Remember, this is the Taylor series expansion about expansion of fx of sin x about x equals to pi by 4. Similarly, you may be asked to find out pi by 3. So 2 pi, not 2 pi, maybe pi by 4. Or you can be asked at 3 pi by 4. Several other topics can be there. So this is what we have in the second example. Now it is already late, so I will. Once you follow these two examples, then I think you will follow the other two examples also. So yeah, how to find the value of cosine. So you can write it cosine of 30 plus 1. So this is 31 actually. Okay. 31 degree. You write it as this form, and then you use Taylor series formula. So this would be, yeah. So this is nothing difficult. X plus h, you 40. So here you get 1 degree is pi by 180 degree. So that's a crucial step. Okay. And x equals to 30 degree, you take it. And then you write the Taylor series formula. Because you have to make it up to 4 decimal places. So that is why you will take final answer will be 4-digit number. We will approximate it. So 717, you can write it 72. Okay. So that's how you calculate per example. And if it is asked to find out the Maclaurin series expansion of this function, where m is a constant, then the Maclaurin series by definition will be of this form. And then you define it, y equals to fx. Try to find out the value of y dash x. And all other derivatives you try to find out. So similarly, I would recommend you go through it and verify. If you have doubt, ask me. I will try to explain. But it is given here. So yeah, try to solve these problems. These are possible answers. I would stop here, and next class we will discuss some new topic. But before that, you try to finish all the exercises. If you have any doubt, you can ask me regarding today's class. In fact, previous class also.